Hello everyone, I'm Sagie from Huawei European Research Center, and I'm going to present a topic we call dynamic service injection. Before I start talking about what it is exactly, I want to speak a little bit about why we are doing this. So Dragonflow is another open source project we are doing. We are going to present it tomorrow at the networking track. And I don't have too much time to get into Dragonflow, but the thing is we wanted to keep Dragonflow very, very simple. Okay, very simple in terms of the code base, very lightweight. But as we moved along and as we gain more users and more people, we keep hearing all kinds of different requests, different application, different networking services, different behavior after routing, before routing. And it contradicts our simplicity. So we needed to think about a model to extend Dragonflow without actually writing code inside of Dragonflow. And topology service injection is all about that. We have Neutron Abstraction. I hope everyone is familiar with it. You can build these beautiful topologies that looks like and act like you'd have physical networks just for your virtual topology. And we have a lot of solutions, a lot of open source solution, a lot of closed solution that implements Neutron API. We have centralized controllers like ODL, like ONOS. We have distributed solution like Dragonflow, Midonet, OVN, and others. And all of these solutions take Neutron API and Neutron elements and compile this to a packet pipeline in all the compute nodes in our setup. This is usually, and again, some solution has it, some don't. This is usually an open flow pipeline that is implemented in OVS in most of the solution I listed here. And they are implementing layer 2, layer 3, and so on. But we want networking services. We want additional behavior. We want different behavior. Some users want this, some users don't want this. And in all of these solutions that I listed before, it's rather hard to insert or interfere with their pipeline or in their logic unless you're writing in the project itself. Okay, so each project offers applications or offer their core network services. And then we thought in Dragonflow what kind of models we want to be able to extend to meet our requirement. And we first look, of course, about service chaining. So service chaining coming from the physical world, where we had these appliances, each doing its own thing. They were wired one after another. In the world of NFV, we have all of these appliances being virtualized. And we have these functions where we classify traffic, insert it into a specific chain, and then it traverses all of these functions on the way. And there are dynamic service chains, there are static chains, there are new protocols that are invented in order for specific function to return result to the infrastructure like NSH, and some are using MPLS. But to us, when we looked at service chaining in general, it wasn't quite what we were looking for, because all of the solutions, there is this Neutron SFC API that defines, and all of the solutions, or most of them, are trying to implement it. But still, for the infrastructure itself, for the networking solution, it's just traversing packets to and from these functions. What we wanted to achieve in Dragonflow is having an external application, and this application could be centralized. It could run on another controller, on ODL, SDN application. It could also be a distributed application running at a container or a VM in our setup. And we wanted to allow this application to have a secure API, which look like OpenFlow or P4 or something like that, that actually allow it to install logic inside our pipeline, to enhance our pipeline. And the important part here is securely, because we are actually want to offer this as a tenant service. Okay, so a tenant could take his application, and this application can insert logic inside our pipeline. And this has to be a secure thing because we don't want one tenant to interfere with the traffic of another, because we are now touching the infrastructure, the open flow pipeline. And this is the model that we came up with, topology service injection. In essence, what we are doing here, we are telling the application, and it doesn't matter if it's a centralized application, if it's a distributed, you are now managing the logical elements of our topology, okay? The logical ports, the logical switches, logical routers, logical switches like Neutron network, router the same. The process as we see it is that the tenant or the administrator register its application or service. It then gets a specific token from Dragonflow and then can attach its application to any logical elements in the setup. Okay? One or a group of these logical elements. And by doing this, we are basically saying, we are basically ensuring our requirements to offer this as a tenant, because a tenant can only attach its application to logical elements that this tenant owns. And Dragonflow essentially enforces this. It takes the core pipeline that implements layer 2, layer 3, and all the additional services, and adds and compile in a distributed way the new pipeline with the additional applications. What we see here is an example, again, of a simple service chain with an IPS VM. And this is talking a little bit about how this is deployed. So as I mentioned, we could have a centralized application, SDN. It can run separately or another controller. It talks with the Dragonflow manager, and it has OpenFlow or P4-like API, and it installs and basically manages the logical elements of our setup. And what the Dragonflow manager knows is to distribute this to all. We have a local controller at each compute node. It knows to distribute it to the relevant controllers, and they know to compile the pipeline and install it correctly, depending on the elements that you control. The same thing, the same application could also be inside a VM. Okay? Inside, we saw a lot of cases where we have what I call classic service chaining. We have these functions sitting in VMs or in containers maybe in the future, and the IPS, and it still wants to use this API. So our local controller knows to hijack these API calls, transfer them to the manager, and they are dispatched to the entire environment. And of course, a hybrid model combining the two. This is a quick example of why topology service injection is powerful in conjunction with service chaining and why they complement each other. In this example, we have an IPS function that can sit on the data path. It can get packets and inspect them, or it can even get mirrored or tapped traffic. And then it suddenly recognizes an infected VM. It has a Trojan horse or a malware. And the thing is that that with topology service injection, we can now block the VM at its source. We can have it install flows that block the traffic when it notices it. This is something we couldn't do if if the IPS was getting tapped or mirrored traffic. This, of course, reduces the overhead on the IPS because it doesn't have to get packets right now. We have the same scenario can be for the positive side, where our IPS basically inspect the first packets of the connection and then do a wiring between the two VMs directly. And these are just, again, simple scenarios. We have other use cases, for example, implementing applicative load balancing, where the load balancing receive the first packets of the connection and then wire the client and the server directly. We have another very interesting use case that actually other companies are pursuing, and this is we have a flow analytics machine that is getting flow export, S-flow statistics, and it detects elephant flows in our setup. And then it wants to install tagging flow, DHCP tagging flows on this. Topology service injection enable this use case in a relatively easy way. And we believe that this simple approach of actually managing the logical elements of our setup makes sense for some applications. And it's not something that we only see as a Dragonflow solution, but something that can work for other solutions out there, like OVN, the centralized controllers, and so on. So if you are interested, Dragonflow is having a design summit. It's an open source Big Ten project. You're all invited to come, speak with us, and get a little bit deeper information about this feature. Okay? Thank you.